Hi, my name is Jamil.
Jordan. I'm Mike.
Keone. How you doing?
I'm Juwan.
And I'm Najib.
Alright guys, so what we're gonna do first is plan out the experiment. The experiment that we're doing is the egg drop. We're dropping an egg from a building and we're gonna time it perfectly so we can hit the professor, Tony, so we hit it right on the head. First of all, we're gonna plan it, and second of all, we're gonna go out to the field, make the measurements, and see what numbers we're gonna be using and plug it into the equation and all that, good stuff, and then got my boy Sherv finding it out for me. And then third, lastly but not least, we're gonna go out, do the experiment, see if the numbers we have are correct, and if not, try it again. But I'm sure we're gonna get it on the first time because we're perfect, SOS, yeah, you know what I'm talking about. So basically, yeah, so I'm gonna plan it out, measurements, apply the measurements to the field, and then set up a good game plan like the Huskies, and then go for it. Ready, set, go.
Jamil, I got a question.
Yeah.
What do you? Can you move to the right a little bit?
Yeah.
What do you mean by doing the experiment theoretically? What does that mean?
Well, theoretically is what the numbers are supposed to be when calculated, and then experimentally is we do it and get the numbers, see if the experimental and the theoretical match, and if not, we can come up with the percent error. But I don't think there's gonna be any error,
So we can actually prove if all this mumbo jumbo motion equation stuff really works.
Exactly.
Huh? Nice.
They're pretty smart for a cameraman.
What do you think about that, Shervin?
Sounds good.
Sounds legit.
Sounds legit.
You guys ready to go take some measurements?
Yeah, you guys also might know me from audio recordings past, such as Big Bang My Ass and personal audio recordings.
Alright, this is our theoretical model of our egg drop. First, we need to know the height at which the highest point when he throws the egg up, because he's throwing it up. So we're gonna need to know this height. We're gonna call it x. We're gonna need to know the angle thrown. I'll draw bigger. It's gonna be this angle right here. We're gonna call it theta. And then we're gonna know the velocity of the egg when it hits the person on the head.
We're also going to want to know the distance, because we're going to have two X's on the ground from where he starts walking to where the egg's going to land on him, or at least we wanted to stop so the egg lands on him. So we're going to need the distance, calculate that. Then we're also going to want to know the height of the person so that we can subtract that from the building height and be able to make the experiment work.
I have a question. Do you mean the height of the drop?
Yes, the height of the drop. You want to subtract his height from the height of the drop. And then finally, you just want to know the velocity of the person, how fast he's walking, so that we can judge the speed and factor that into the equation to make sure that the egg lands right on his head, because that is what we're shooting for. So basically, we're going to be finding the time that it takes for the egg to drop and land right on his head when he hits this X right.
Hey there everyone, it's Mike. We're at our side of the experiment and we're going to measure the height of the release point all the way to the ground. So here we go.
The release point's going to be from the tip of my hand, so right here.
Why don't you let it go down with it?
Yeah.
How high? Say it loud.
Right, 19 feet, 9 inches.
19 feet, 9 inches.
Big bang. Okay, ready? Here we go. Basically, what we're going to do is we're down here at the side of what's going to be the little act of horror. Basically, we don't want to put a red X on the ground. It's going to be too noticeable. So if you come over here, there's already going to be a natural X basically here. Okay? And we can use that as a marker. And if you look up, that's where we're going to be projecting this projectile from. So you come over here, we're going to measure, this is where we want impact to occur, is another natural X. And as you can see, it's 11 feet. Exactly. So here's our would-be victim now. And what we got to do is we got to subtract the height of the person, right, Keone?
Yes, sir.
All right, so he's going to take this. We're going to do his height in inches, like all the other measurements, but then we're going to convert him back into what?
Meters.
Got it. Here we go. All right. We got a height of 69 inches. What do you know? All right.
Good number.
Round number there. Camilla, you approve?
Approve.
Make the camera go like this. Yeah. So basically, here's a simulation of the distance it's going to be from the two x's that we did simulate outside. So what we're going to do is we're going to have him walking, and at the speed he's going to be walking outside. And as soon as he hits this point, we're going to hit him on the stopwatch. And Keone's going to drop his hand, and I'm going to hit the stopwatch again. So we'll know the distance and time. We'll find velocity.
Sounds like a plan.
All right. So what do I hit to start this stopwatch?
Go.
Good. So that was a couple seconds. We got it down in perfect time. We're going to go inside and do the calculation.
But we just finished our measurements from outside. Those are our experimental measurements. We are trying to find how long after Shervin hits the first X, which is the initial point he's going to start walking at, does Najib have to throw the egg so the egg could hit his head exactly. So we found that the total distance of the release point to the ground is 19 feet and 9 inches. Using these simple conversion factors, we get that height would be 6.02 meters. We then measured how tall Shervin is, and he comes out to be 1.75 meters. We also measured the walking distance from the start point to the stop where we are predicting the egg will hit his head, and that is 3.35 meters. So, and we also have Shervin's velocity because we measured the time it takes, which is 1.9 seconds for Shervin to actually walk these 3.35 meters. We are going to take these numbers and plug them into the motion equation position as a function of time, because we are trying to solve for time, and we have we know the positions, and from outside the experimental measurements, we got the total distance from the release point to the ground. We also found the distance from the start and stop position, Shervin's height, and also the angle that it will be thrown at is 60 degrees. That's what Keone touched upon last time. So we figured out the total height minus Shervin's height will be 4.27 meters, and that's basically the point at where the egg is going to hit Shervin's head. And now I'm going to turn it to Shervin to finish off the problem.
Alright, so Juan figured all these out, and I'm going to take this and get Najib's initial velocity of the egg. So in order to do that, we're going to use this position as a function of time, and what we're going to get from here, instead of t, we're going to substitute it into x over v0, which is time. Now from there, we're going to go y final minus y initial equals v initial time, which we got over here, minus 1/2 g time, once again squared. Now what we get is the distance from the egg to my head, and it is negative because it's going down. And once again, we have v0 sine of 60, which is the angle that Najib throws the egg at, time, which is 3.35, the distance, over v initial cosine of 60, minus 1/2 g 3.35 over v0 cosine of 60 squared. Now the v0s are going to get canceled out because you're multiplying them, and we get this equation right over here. Now after we do all the calculations, we get 2.36 meters per second, which is the minimum velocity that Najib has to throw the egg in order for it to hit my head. Now Najib's going to step in and finish up from here.
Do my backside. Alright, so Shervin figured out the minimum velocity that I have to throw that egg to hit him. So basically, it's going to take, if you take 3.35 meters, the distance that I have to travel, and I also have the velocity I'm throwing it, we find seconds because we cancel out the meters. 1.4 seconds it's going to take for my projectile to get there. Shervin's time is going to be 1.9 seconds. There's a 0.5 second difference. So I am going to have to give him a 0.5 second head start. After he crosses that X, I can release my projectile and it will hit him dead on in the head at the second X that we marked. So basically that's what we have. We did all the calculations, And now this is the theoretical part. We're gonna go actually do the actual experiment outside and put it to use. Shervin, say your final words. How does it feel to be a human condom? You're representing Sigma Chi.
Everybody's in their position. There's Shervin, who's about to get egg. There's Najib, he's gonna throw the egg, and here's Jamil, he's gonna time, and Keone, he's just gonna observe. And do it at, Najib's gonna throw it at 60 degrees, and Shervin's gonna mark when when he goes. Alright, start walking.
Say it before you mark.
Alright. Go. Hey.
Trial. The first trial, the egg hit right where we predicted. That was our final position at 11 feet. Oh. Okay. Trial number 2. Round 2. Go ahead. 60. Is that 60? All right. Okay. What was the time?
0.5. Everybody gave it a 0.5 and it hit exactly what we predicted.
Yay. Alright. Okay, the end. Say bye. This took all day, by the way.
Physics for life. Woo.